So in lesson 3, we're going to take a much deeper dive into the analysis method and offer some tips along the way. So let's get started. Okay, so the overall process can be broken down into 6 main steps. Starting at the top, we start by either identifying or refining the study area and or quarters. Alternative quarters that don't meet the purpose and need are eliminated from further study. And as we just discussed with Q&A with Pete, the intent of the A study is to remove quarters for something other than not meeting the purpose and need. So that may already have been done from a prior planning study. So those quarters that do meet the purpose and need are further evaluated to a conceptual planning level to allow them to be compared and evaluated against each other and their relative impacts. So the analysis conducted in step 3 is not intended to be a PD&E level analysis. It's just a high-level analysis that allows for comparing one against the other. And then in steps 4 and 5, the evaluation is summarized quantitatively and qualitatively, and finally documented in the ACER as part of the final step. Next slide. So remember, we covered this slide at the beginning. The intent of the process is to provide you with flexibility. So it allows practitioners to use a best fit approach based on where you are in the process and how much information you have available. So to summarize, A's can be used to refine a study area or progressively refine a corridor. Next slide. So let's start with the first option. When the goal is to refine the study area, it may be helpful to segment the area geographically into distinct regions. Then through collaboration with agency partners and stakeholders and using high-level GIS analysis, the study team can identify avoidance areas and help focus the analysis on remaining and more suitable areas. When the goal is to identify or refine corridors, ETAC commentary, GIS analysis, and stakeholder input is used to determine constraints. And then the study team can use those constraints to weave a corridor path to avoid the constraints to the greatest extent possible and minimize environmental impacts while still achieving the purpose and need. So on this slide, we're going to cover an example. This is the US 301, US 98 Clinton Avenue intersection realignment study. The project used the ACE process to identify alternative corridors for realignment. So along US 301, there are 2 closely spaced intersections. And if you look at the top graphic on the left, there's 2 yellows back to back. So the purpose of the project was to provide alternatives that realign US 98 to remove these closely spaced back-to-back intersections, facilitate east-west travel, maximize benefits to improvements planned for Clinton Avenue, and enhance safety. By realigning US 98, you would in essence eliminate high volumes at one of these 2 intersections and potentially help reduce the existing high crash rate. So the ACE project process was used to identify initial corridors, refine and eliminate corridors for this particular study. At the end of the study, corridors A, C, D, and E were all eliminated and only corridor B was recommended to move forward. So when the purpose of the ACE study is to identify, evaluate, and refine corridors, one of the first decisions you're faced with is, well, how wide do I set my corridor? So width should be wide enough to provide you with flexibility to allow you to shift the alignment as you need based on avoiding potential impacts. So corridor widths can narrow as the study progresses, but they can start anywhere from 1,000 feet or greater and slowly tie down or narrow down to a typical section width. A good rule of thumb would be, let's say your typical section is 300 feet, then you may want to add at least 300 feet as a buffer on either side of the typical as just a good rule of thumb to provide you a corridor that's wide enough to give you that flexibility that we were talking about. You also want to consider design elements. Design speed is a function of the type of facility and controls a lot of the geometric elements, specifically, for example, horizontal curvature. Typical section estimates should also be based on the anticipated lane widths. So how many lanes do you anticipate, and what is that based on your projected traffic, initial traffic? Next slide. So here we're showing the I-4 Poinciana Parkway. The corridor width for this particular study was based on 2 things. They had a projected typical section that was 400 foot wide, and then they used 500 feet on either side to buffer the typical, providing for a 1,400 foot wide corridor width. Notice they also expanded the study area at the potential interchange locations. You can see that on the graphic. That provided them a lot of flexibility when it came to the interchange concepts. Here's their typical section. Here's a 400 feet. Notice the areas on either side where they also included some room for potential multimodal improvements. Here's another example. For the State Road 836 Southwest Extension Study, an earlier planning study had already been conducted by the agency, allowing for a more defined typical section right from the beginning, at the beginning of the ACE process. In this case, since we already had a defined typical section, the total width selected for this study was 500 feet from the center line on either side for a total of a 1,000-foot corridor. In this particular case, the initial traffic was based on providing 6 lanes of traffic for part of the corridor and 4 lanes for another part. But the corridor width of 1,000 feet was maintained throughout, and it was based on the larger anticipated typical. Purpose and need goals generally represent greater community visions. So these are typically aligned with system linkage, traffic demand, economic development, and safety. So on this slide, we're showing you some sample common criteria used to support each of those. But in each case, it's important to select criteria that not only represents what you're looking at, but is achievable based on the analysis that's going to be conducted during the study. So one of the most important things to consider when you're scoping your ACE study is to bring in those experienced practitioners to allow you to scope the right amount of traffic data collection and analysis to support your goals. Next slide. So let's look at a sample. In this project, the purpose and need evaluation used a very simplified scoring system using high, moderate, minimal, and low. Each category within the purpose and need was evaluated and given a score. For example, the ability to improve mobility was based on the corridor's projected traffic, and that was based on annual average daily traffic calculated from the traffic model. The ability to enhance multimodal connectivity was based on how each corridor had access to existing as well as proposed multimodal facilities. It's no surprise in this example that each corridor shown here met the purpose and need. If you recall, this is the same project that had a previously done planning study that already supported that purpose and need. So to summarize, for purpose and need, you can always eliminate based on those corridors that do not meet the purpose and need. That may have already been done. Traffic is usually a driver for purpose and need, so it's important to select the appropriate criteria and make sure you scope your study with enough data and analysis to support it. And finally, when it comes to scoring, you don't need to get crazy, just keep it simple. Next slide. So moving on to the environmental evaluation, that's really based on a high-level GIS analysis. The corridor widths are overlaid on a GIS map. Potential effects are then determined by intersecting the GIS layers with the width of the corridor footprint that was selected. Because the data is so variable, the scoring method that's selected in the methodology memorandum should fit the project and anticipated data collection possible. During our research efforts, most often standard deviation of the mean was used to compare corridors. In this example, we're showing standard deviation of the median, and this was used because the data was not normally distributed. After the data was collected in this example, for each category, it was compared to the other corridors and assigned a value of 1 to 6. 6 categories were selected, representing 6 values and how the data compared to the median. So for example, looking at the impacts that were greater than the median plus 2 times the median absolute deviation, a value of 1 was assigned, representing a high impact category. Notice the color red when with that high impact category, representing the worst alternative corridor for that particular criteria. On the flip side, where the impacts were less than that same amount, a value of 6 was assigned representing a low impact. Notice green was used to represent the best alternative for that category. And the other remaining 4 categories were used to represent 2 through 5, which were high, moderate, moderate, high, moderate, low, and low, moderate. Corridors in this project example were broken into segment links. So the previous exercise was done on a link by link basis. which means those values, the 1 to 6 values, were totaled for each link and added together to get a cumulative score for each quarter. The alternative quarters were then ranked on 1 to 10 based on that cumulative score. Quarters with equal cumulative scores receive the same rank. The higher the rank, the higher the cumulative score, the higher the benefit to the project, or in this case, the lower the potential impact to the environment. As you can see, quarters 6 and 9 scored better from an environmental perspective on this particular project. So here are some of the lessons learned along the way. When it comes to GIS layers may need to be adjusted to allow for proper analysis. For example, you may have point features that need to be converted to polygon. Let's say you have a school or a hospital, which has a point feature, and you try to intersect your 500-foot buffer with that school or hospital, and it may show you're missing it because the point is in the center. If you convert this to a polygon using county parcel data, cross-reference the layers, then the analysis would show the impact that the 500-foot buffer did in fact impact the property. As well, evaluation criteria may incorporate data from one or more layers. You might need to combine a few layers. The study team may choose to ground truth some sensitive areas, so you might need to adjust some layers to add that ground truthing information. And then again, new layers may need to be developed. You may have a particular resource where an agency does not have an up-to-date layer, so keep that in mind as well. During the analysis, make sure to clip the polygon layers to capture the impact. For example, shown here on the top right are potential acres of wetland impacts that are impacted by the 500-foot buffer. And finally, color coding the analysis helps the reader to visually see the impact. Notice the red and green ties to the 1 to 6 values we mentioned before. Moving on, the environmental evaluation, as you know, is one of the most complex activities done within any study, and that's due to the amount of data that has to be collected and compare. When determining the method to use, perform a high-level testing of the scoring method to make sure it's the right method for you. Consider a simplified scoring method for the environmental evaluation. We just presented a 6-tier ranking, and that ranking was needed because there was very little differentiation between the data that was collected. You might be able to use a much more simpler 3-tier or simple ranking of alternative corridors as well. Some issues may not be quantifiable, and you may need to rely on the experience of a professional for that degree of impact. Next slide. The engineering evaluation should consider factors that have the potential to impact the project design as well as cost. Typical factors are shown here, and basically you want to capture anything that would significantly affect the project, add complexity like major utility conflicts or railroad crossings. Cost estimates should be done as well, and they can be based on long-range estimates and typical cost per square foot models for complex bridges. Next slide. Some tips on the engineering evaluation. You can use a similar scoring when it comes to engineering. It could be very simple, yes, no, or ordinal ranking. On this slide, we're showing a ranking system that uses low, medium, and high. Sometimes it may make sense to capture the complexity of the engineering factors. Here's an example. State Road 31 extension project shown here use a complexity rating based on a scale of 1 to 5 to capture the complexity of the design related to drainage and stormwater. The ratings were based on corridor length, anticipated pond sites, impacted permits, floodplains, drainage crossings, and impacts to existing drainage features. In other projects we researched, user benefit analysis was used to capture the economic benefits of the improvements compared to the alternative corridors and how much they cost. So consider providing that type of analysis when it makes sense. Sometimes the best corridor is also the most costlier, so you want to get that perspective as well. Some projects have unique issues that really don't fall into any one of these categories, but you should assess them as well. In this sample project, the corridors being evaluated contain segments and links that went beyond or bordered the urban development boundary. The county's comprehensive development master plan included restrictions related to building outside of this boundary. So for the ACE study, a review of the county requirements and policies, as well as an analysis, a high-level analysis of how the corridors performed and their proximity to the urban development boundary was conducted as well. And then finally, public involvement and agency involvement is critical for all projects, whether it's PD&E and ACE. It's really necessary to make sure that you're communicating with the public and with the agencies and all your stakeholders. And as with PD&E, there is no one size fits all. You really need to tailor the approach to your community, to the project, and to the needs. So traditional approaches used in PD&Es can work as well. But the most important aspect of public engagement for ACE is to make sure that any unresolved issues in ACE are followed up during the subsequent phase. It helps to build consensus and maintain trust. So moving on, we have various engagement techniques, similar ones as to PD&Es. And in the last year, I think we've all learned how valuable virtual engagement techniques can be. So opportunities for virtual engagement can be combined with in-person events and offer the best of both worlds, providing accessibility based on your preferred method. Our research indicated that most studies included at least one or more public workshops, with a quarter workshop held at the end to present the results of the evaluation and solicit input. Throughout the studies that we researched, various different types of stakeholder involvement meetings were held, whether that was meeting with HOAs, community groups, cities, elected officials, all of that. Project advisory groups were used to a lesser extent, and when they were used, it was important to make sure that the groups understood their role and the expectations for the process. So after completing the analysis, the portion of the ACE study, a narrative assessment is prepared for each quarter. This narrative assessment should summarize the advantages and disadvantages or limitations of each corridor and highlight any unique factors that could affect decision making. Next slide. This narrative assessment can be accompanied with a high-level exhibit, like here, shown here as a quick example that allows you at a glance to see what the advantages and limitations of each corridor are. So let's point out a couple of things. Note on this particular example, this alternative results in fewer impacts to residences and business owners and property owners, but also has the highest potential for Section 106 involvement. So this was done for each quarter, and it allowed the reader to quickly compare each one against the other. Next slide. So at the end, it's recommended to summarize the evaluation conducted for all categories. Note in this example, columns 5 and 6 also capture the stakeholder sentiment for each alternative quarter. And finally, the last column identifies which quarter or quarters are recommended for further study in the PD&E and NEPA phase. And I believe we're going to switch to Pete for a quick poll, and then we'll go to questions after that.
Perfect. Thanks, Sylvia. All right, let me launch this polling interface and see if we can get some participation. Okay, and I should be launching it. Okay, great. So the question is, select all the main analysis categories that are common in an ACE study. So regardless of where the project's located, select all the items that, whether you're in the Panhandle, whether you're in Miami, and you're working on ACE, what are the topics that you would expect to hit in the methodology memorandum and also document in the ACE study itself? I'm going to give it a couple minutes. And remember, it's select as many as makes sense in your world. Okay, we've got about 60% participation. Just going to give it a couple more. Okay, I'm going to go ahead and close the poll, and then I'm going to share the results, and we'll talk about it for just a minute. Okay, so as you can see, we've got really good response on purpose and need, environment, public, and stakeholder input. However, engineering is also always discussed in ACE, how it's discussed, what's important. All of those elements were all topics that Sylvia and Ted and Chris have all spent time on, and they would be consistent. What would really depend on your project is the level of detail you're going to go through each one, but all of those various topics are all topics that would be covered in ACE, and the uniqueness is really kind of tied to your project and what are you trying to accomplish at this particular point. So I'm going to hide this particular poll, and we've got one more poll, and then we're going to open it up for any questions. Let me launch this. Okay, and the question now is select the answer, the best response. How are corridors eliminated in the ACE process? So we're going through the ACE process. How do we actually eliminate a potential corridor? Pick the one answer that makes the most sense. Okay, you guys just saw me figuring out who's going to answer the question, and you just saw me tell the whole entire group. Okay, we've got 76 responses. I'm going to close the poll. And as you guys saw, we did receive a question from Kurt, and I'm asking Sylvia from our team to address it. Let me go ahead and share this result, and then we'll address that question as well. So the question again was, select the main best response for how our corridors eliminated in the ACE process. We had a great number of responses, north of about 80%. And you can see the vast majority chose not meeting the evaluation criteria in the methodology memorandum, which is correct. And all of those other reasons can be reasons in your methodology memorandum based on how you developed your methodology, how it got set up, how it got approved by the lead agency. You may be eliminating because there's too many impacts to environmental resources. You may, in your analysis, determine that there's a high cost and what the bar is and how you're going to do the elimination. If there are public controversies on the project, that could, within your methodology memorandum, be a consideration that tips the scale on whether or not you would eliminate anything. But the key to the entire thing and the part of the ACE process is your methodology memorandum is unique to your project and your circumstances and what you're trying to accomplish uniquely on this project. And you're doing it in a coordinated, vetted way with your stakeholders, with the public, and then you're getting buy-off and approval from the lead agency, whether it's OEM for the federal projects or whether it's the district environmental leadership because it happens to be a SEER. But in all instances, you're basically approving that methodology. So that becomes the standard by which during your evaluations, that's the standard you're being held to. And it's very unique, but it's also what's established in that approved document. So I think everybody got it. And even if you answered something else, really that just funnels back into the MM as well. So I'm going to hide this, and then we do have some questions, and I'm going to go ahead and read the first one, and I'm going to ask Sylvia to hit it. Okay, so the question is, you recommend a wide corridor width for analysis, but wouldn't that skew the results of the analysis since the results include a buffer area also? The GIS analysis will give you fatal flaw areas that need to be avoided, and it may be difficult to avoid those with very wide corridors, 3 times the typical size of right-of-way needs. How would you answer that?
Oh, thanks, Kurt, for that question. It's a great question. So again, every project is a little bit different, and let's say you've done a land suitability analysis, so you know where those fatal flaws are, then maybe it makes more sense to narrow that corridor width and select a smaller buffer. The buffer is there to provide you flexibility. After you do your analysis, if you come into a resource that you have to avoid, then you can use that buffer distance to avoid it. Buffer can also cover the interchange area. So rather than having a corridor width that does this, you can select one that's large enough that it covers your potential interchange concepts that you're looking into. And if you have more information, you've done a previous study that identified some initial quarters and you have a really good idea of what your typical section is going to be, then maybe you don't need to increase it. And I think we showed examples of that where it was a minimum of 1,000 foot. We could have done a little bit less, but in that particular study, we did have areas that came out to be sensitive from a cultural resource perspective, and we were able to use different techniques, whether it was going around them or bridging those constraints. Does that answer the question?
It did. That was a great answer.